Hey guys, this is Ben here. I'm going to do a quick example of the Amazon Elastic Container Service running Fargate. I'm going to be using Amazon's ECS CLI, which isn't really their AWS CLI. It's like another project that they have built on top of it. I can't recommend this CLI really for any big projects. This is going to be a very simple example using one Docker image, and the containers aren't going to be talking. So it'll be pretty easy. But if you're using Docker Compose engine a lot, don't use a CLI with Fargate at least, because it's just I think they did a bad job with how they presented it and what it's really for. But I'm going to show it on a simple example, which I think is really what it's for, a very high level command. So hopefully we get a good amount on it. Things you're going to need are pretty much the Amazon an account. You're going to create a execution role using ECS service execution that they already have, and then you're going to need a VPC and a subnet and things like that. So let's just jump in the computer. I have a really simple application here. It's index.php, HTML page that will change the color. So it's going to be really simple. I'm running this on a Docker file that's using PHP behind Apache. I'm copying all my files and then exposing port 80. I'm going to run all this on port 80, by the way, because it just makes everything a little bit easier and quicker. And then I'm going to be using, here is my main Docker Compose file. You should be using Docker Compose when you use this, but if you get complicated in Docker Compose, then don't use this. Maybe use AWS CLI or something, because this ECS CLI is not good for, it just doesn't work out for me. And I haven't found a good solution yet, but hopefully I will in the very near future after I do this video. All right, so I'm going to just build this to show you exactly what we're working with. I'm inside the directory here, as you can see, and I'm going to sudo docker compose, and I'm going to put this up. So it should build my image here, and then I should be able to go to my local host and see that this is our page. So this is what we want. So now the whole goal is to launch this in Amazon now that you have your application running. So you want to get this in Amazon, you want to get it behind a load balancer, maybe hook up some auto scaling or something like that. So what I'm going to do is I'm going to open up Amazon. I'm going to open up the EC2. I'm going to open up the container service, and I'm going to open up our CloudWatch. So these kind of make up everything that we need here. So don't want that. Let me see if my CloudWatch has any of my other stuff. Okay, cool. Okay, so why I'm opening up EC2 is just so we can see the load balancer and get some ideas from here. Everything should be empty on my account right now. I'm going to be using just the default VPC and things like that, which I don't really use for anything else. All right, so let's get started. I'm going to put my project in GitHub, so you should be able to see everything I'm doing and follow along. And I'm going to put a notes.txt. I'm going to remove my variables, but these are the variables that I'm going to be using to launch these things. I don't like typing things over and over and over again. So I'm going to kind of just take these right here, and I'm going to paste them in here. Good. So now we have all my variables in place. All right. So our first step is you need to create a container registry, and what that is basically where it holds your images. So you're going to build your container, make an image out of it and push it up to them. So the first thing you need to do is have the AWS CLI going and the ECS CLI, and I'll bring that up, the ECS CLI, because it kind of explains some things. You can see how to install it in here. Really how they organize this compared to the actual developer guide is a little bit crazy. So you have to go back and forth a lot to really understand how everything is going. Let me see if I could find, not the developer guide, the command line interface. This is not for that one. Let's see if I could find the ECS command line interface. There we go. So you kind of got to go back and forth because there's some examples in one and no examples in the other one. We're going to be focusing on the compose, not necessarily any of this, because it seems to be using a lot of CloudFormation, which is great. Like everything we should be doing in here should be put into a CloudFormation script. But for simplicity, we're just going to be typing it in ourselves. And that's also why this is a notes.txt and not a bash, not a shell like .sh, because you guys shouldn't be taking this and just running it, because that would be a little bit crazy. So we're going to create the registry here. Let's jump in. Okay, so our repository name is probably going to be, it needs to be probably something lowercase. So let's just see what I have as my repository name. So we're going to change that here. Everything really should end up being lowercase. So I'm actually going to pause for 1 second and then lowercase everything, because that just makes everything a little bit simpler. All right, so everything now is lowercase, as you can see. And let's run our last command again. Not everything has to be lowercase. You kind of have to comply with their rules, but I just made everything lowercase to make it simpler for me to do this tutorial. All right, so this is the output here, and we're really going to be needing this URI. That's where you're going to be posting your actual container or your image to. So if we check in our ECS, we should now be able to refresh and see, it still uses me. Let me get started, it's still there. Okay, so now in our repositories, we have our example repo. And you can see that this is the same URI. We're going to be using it a lot. So I'm going to actually take this URI and put it as a variable so I could use it later in these commands. Okay, so our next thing we need to do is create our image. So right here I'm going to be building our image locally using Docker. I'm not using Compose to build this. So you should see it. There's probably a whole bunch of images in my images area, but you should see it right here, example, and I have it with this version tag. And we use this version tag here because we're going to be using it at the end of our image, because the ECS CLI compose up, or whatever the start command, will not recognize you've changed your build or you've pushed a new image unless you change something in their YAML file. So that version now will be in the YAML file. But we're going to go into the YAML file in a moment to show you what is necessary for that. So next we're going to tag our container image to our repository using that version. And we're going to pull the login. So you need to get a token in order to push your image up to your repository. So you could just run this wrapped command and it'll just do it for you. You don't have to repost anything. You can see here login succeeded. And lastly, we're going to actually push it up there. My internet is super slow, so I might have to end up pausing this and resuming it. It like cuts out, and then I have to restart Docker in order to finish posting this or pushing it. But hopefully it runs in one shot. Anyways, I'll be right back in a second when this finishes. Okay, so just to give you an example of what happens if yours pauses or if it freezes in the middle of the push. I'm in the Caribbean in Grenada, and I have really bad internet routes from here. I could get good internet to down the street, and besides that, nothing else works. So I'm going to actually stop this. I'm going to do sudo service docker restart, and so it's going to restart my Docker service. And I don't know if that's great to do, but that's how I do it. And then I push it again. It doesn't redo everything. It only pushes those layers that didn't successfully get pushed before. So hopefully this time, now that not all the layers are going, it will eventually get pushed up. Sometimes I have to use a VPN to kind of help my routing or change my DNS. This is life for me, and this is kind of how I do it. So hopefully in a moment, I'll have it pushed up for you. Okay. I ran my VPN and I got it working. So, all right, so I'm pushed up to the cloud now. Let's clear this and check. We should see if we refresh our repository, our new version here. So this has our tag, which was the version number. And since it's our first one, I have it as version 1.0.0. This is not a lesson on versioning. So we're just going to go 1.0.0, 1.0.0.1 or something. We're just going to do it like that, make it really easy. As you can tell, though, in our task definitions, we have no definitions and we have no clusters at the moment. So we're going to start creating those. So let's jump back in here, and our next step is to build an empty cluster, and then configure our ECS CLI. So our cluster name, let's run our cluster here. So our cluster is created, and if we go in here, we should now be able to refresh and see our new ECS CLI example cluster. Next, let's go and configure our cluster. So we're going to be running a configure, our cluster name, our region, our config name, and the launch type, which is Fargate. Because that's what we're doing here is Fargate. And we're going to make that configuration our default. So you should see, if you go into Vim, you should be able to see your config, which has your clusters. This is an old cluster, which now I could remove because we now have a new cluster here, which is our example cluster. So that's the one we're going to be using today. So let's quit this and clear this. So after we created our cluster, this is pretty much local. We're going to create our load balancer. You have to create your load balancer before you create your service. If you create a service, you will not be able to add a load balancer to it afterwards. It is in the information on the ECS compose. If you go to compose a service, it should mention a load balancer in here, and you will not be able to let's see, when a task service, either way, it says that you cannot somewhere that you can't add one later. So that's kind of a bummer and a pain in the butt, but that's just how they do it. So we have to create a load balancer first. So here I'm going to be using a network load balancer. You could use an application load balancer if you would like. I'm going to be putting it in the same subnet as my service. So I want it in the same subnet. So let's go in here and create my load balancer, and we should get some information about my ARN. I'm going to take this and I'm going to make it a variable so I could use it in the near future. And now if we go into our EC2 management console under load balancer, you should see your load balancer that you created. It's still provisioning, so give it a moment to do that. And while it's doing it, we could go in here and create a group. So this target group will connect then to our container, and it will push the ports over depending on how you specify it from your load balancer over to your container. So we're going to create our target group, and you have to use a target group. If you're using a classic load balancer, you don't have to, but if you're using Fargate, I don't believe you can use a classic load balancer. So, and there's no reason to be using classic load balancer anymore because we have all these newer options that could help with ports and stuff like that. So let's take the group ARN, and we're going to be putting that into a variable so that we can use it later. All right, so let's clear this. So now you should see also under your target group, and you could do all this in the, if you want to, I'm going to create an old or delete this old one. You could do all this in the just like the console, but that doesn't help you later on when you want to actually build this out and have it deploy and run correctly. You don't want to be building this each time. You want to have it as a CloudFormation script and you know, organized so you can put it in your code build and all that stuff, your pipeline. So let's go into, just to double check target group, I put TT. That sucks. Anyways, doesn't matter when you're using the variables. So now we're going to connect the target group to our load balancer as a listener. So right now you could see in our load balancer, there's no listener. So we got to add one. And how we could do that is that command right there. We're going to be using port 80 as I mentioned before. Just makes everything easier. Okay, we don't need any of this stuff. Okay, so now let's go back into here, and we're going to, when you're building these containers, you want to log whatever you need. You could go into logging crazy by yourself, whatever. I just have it set up really simply so that we could at least see and troubleshoot these logs. Without that, you'd be kind of lost. So now we've created the log right here. It's just creating a log group, which we're going to use later. And if you go in here and refresh this, that's now our log group is right here, which is really handy when you're trying to configure and manage these things. All right, so now we're getting into the actual stuff that comes in with Amazon ECS CLI. So before we were using Docker Compose, and we were using the ports, port 80, build here, really simple stuff. I'm using Docker version 2 because it seems like the ECS CLI is not compatible with version 3 yet. So I'm just using version 2 so I don't get caught up. The ECS params I actually even have in version 1, which is really bad, but that's how it is. That's how they have it set up, and that's how we're using it. So you need really 2 files to run your Docker in Amazon. One is the Docker Compose like we have here, except I made one called Docker Compose AWS. So this is like a different environment. I don't use my image from the repository on my local build. I just build it. And I don't use AWS logging here. I just look at it. So I have this set up a little bit separate. So you can see here version 2, here is our service. Here's the image, the repository URI, and the version. So that's going to be used to push up. When we change that version type, this is the file that will be updated, and that's what's going to help you deploy your application and scale and things like that on the newest version or whatever version you're using. Ports is port 80 to 80. These have to be the same when using Docker CLI. So if you're using some Compose to run other services in here and you're trying to forward them over like 5,000 to 80 or 5,000 to 501, whatever it is, it doesn't let you. It has to be the same, which is, I don't know. It's frustrating. And then here's our drivers, AWS logs. You could use other log services. I'm using AWS logs. It's pretty, simple. Region, your log group name, ECS. They have examples of this in their GitHub to kind of go over the, like what you need to put in. So you can see mine is pretty much this. So you could kind of, this is the ECS params. Mine is pretty much this right here. So you kind of get the gist. The next part is the ECS param. So when you create a container, it's going to use a task definition, and that definition needs to be defined. Usually it's in JSON if you're using the AWS CLI, but since we're not using the AWS CLI anymore, it's using the ECS params. So I'm using my role the task execution role that you should easily be able to create that. I'm pretty much using the smallest size. This is a hard limit. I'd rather have a soft limit, but this is a hard limit here. And I'm saying that my service is essential. And the parameters is here's my subnet, my security group. This is not like highly available because I'm using one subnet, and I want a public IP. Usually you wouldn't be wanting a public IP, but just for this troubleshooting, this is how I have it set up. And for this example. So let's jump into, let's see how much time I got in the clock. Okay, so let's jump into, and we're using, with Fargate, you have to use AWS VPC. It's just how they have it. Okay, so let's jump back over here. So we're going to create, using this ECS params and the Docker Compose AWS YAML file, we're going to create our actual service. So what this command is going to do is create the task definition from this ECS params and create the service from this Docker Compose. So, and it's also going to use our target group, so it knows to use that load balancer and what port we're using and the container name. You kind of see it and break it down. The most important thing about this command is that compose is a command, service is a subcommand, and then create is a subcommand from that. So you need to be careful when running these commands or building them out, because you need to go down the line of their command. So you could go with, you first start with compose, and you build out your compose, and then you can see this is what I'm using here. And then you come down and you would create your service, which is a subcommand. And a service is what you're going to use for running like a website or something like PHP here. You wouldn't use a task for that. That would be maybe to migrate your database or something like that. And then you would create your create inside of that. And then create has all these values here. So you need to go through and read their documentation and kind of understand what's going on. Or don't, and just fill out the stuff at the top and do whatever you want with it and hope it works. Okay, so I'm going to run this now. So I just created this. I didn't run it or start it. Sorry, I said I was going to run it. I just created it. So what create does is it creates the service and the task definition. If the task definition doesn't exist, which it didn't. So you can see here, it created one. And this is the first version of it. And the next step would be to start the service, which would bring it basically to the desired service of one task. Instead of using create and start, you could use up, which is basically a combination of create and start. So this is just like a really nice, easy thing to get going. But if you're getting real complicated, then you need to be using another tool. But this is like great for just like kind of like, hey, I want to launch this on ECS using Fargate. Okay, so now if we go back in here, you should see, go away. You should see our new task definition, which has very similar stuff from what we put, our group, our region, our logs, prefix. This is the JSON file that the compose is creating for you. Our image, our repository, our version, all that stuff is like right in here. And then you could go inside your clusters and see that the service is actually running. There's no tasks in here, but if you go to it, you can see it's connected to our load balancer, our group name, which is connected to the load balancers, and it's using that container, which is in your task definition, and the port. Nothing is happening yet. There's no deployments or anything, but you kind of can see, you know, how things are getting started and how things are going to work. So lastly, after this is all created, let's start this. I don't need to tell it what the task definition are anymore. It should actually look for this ECS params by default, but I just put it in there like that just to make sure. And now I could start it. So let's actually, before I start this, let's create a new tab and HTTPing. Let's do our load balancer DNS name. And we should be able to, see if I could not mess this up, get a ping from this. So let's hit start. And it kind of gives you this, it's not great, but it kind of gives you an output of what's going on right here. Another way to do it is going into your console. You know, this isn't the best way either. Really looking at your logs is going to be the best way, but it doesn't tell you much until you are, until the image is started. So basically change this desired count to 1. And now that should kick off to start a task. So if we refresh, we see a task has been started, and in a moment we'll see a public IP address here once it's running and done provisioning. And you kind of see just what it's going with. So it's going to be port 80, and it's going to look something like this. Well, I turned that off, so there we go. It's going to look like that, but that's not running right now. Let's see. Actually, for the sake of this, I'm going to go to my listener. No, let's go to, yeah, our target group and go to our health checks and just put this smaller. I'm using TCP instead of HTTP. You could use HTTP if you do an application load balancer. This is network load balancer. We're using TCP port 80. And I'm going to do delayed registration to like 60 because that's just too long. Let's do it even 30 right now. And I wish I could change the other attributes, but it doesn't let me. Okay, so let's go back, see how our task is doing. All right, looks like it's running. So now we should see it on the IP address. Boom, we have our container running in Amazon. So that's pretty good. Like we got from local to Amazon pretty quickly. If you, go through the process, build a script or something like that, it'd be pretty fast. But really the most important part now is to update our code. And this is a workflow that everyone is going to have a different workflow, and there's no right way to do it. This is just for the example of a simple thing. I'm not saying go into production like this. You could maybe, if you had like a staging account and then this was your prod account or something like that. This is ridiculous to go into production like this though. But I'm going to kind of show you just how to push code up here. So first, let's wait till this load balancer comes and does its health checks on the target because it's still initializing here. So in a moment, it should actually be done initializing and we can hit our load balancer. Let's pull up our load balancers. Oh, we're actually waiting. Yeah, it's already running. So you can see kind of here, it's been running. And we're getting 200s. Don't mind my ping. Like I said, I have really bad internet. All right, so now the fun part. Usually when I do a deployment and I have a, let's say I'm using like code deploy or something like that, you have to have two machines. You put code, you take one off the load balancer, you put code on it, you test it, you push it back in the load balancer while you take the other one out. That's great if you're doing something that like you can't have two different versions for any amount of time. Blue-green is how you want to go, and this kind of does a good job at that, and you don't even need to run two instances. It kind of just handles it for you. So it's actually really great, and I'm going to show you how to do that using just the ECS CLI. This is probably the best part of the CLI, but it has a lot to be desired. So let's jump in and do that real quick. So we're running our services. Our task is running on ECS. Let's go to our service. Everything should be good. We are running a Fargate service. Boom. Okay. And we should have a log. We should have a log that I just did a GET request on that. So yeah, boom. You can see me pinging it, ping, HTTP ping. I'm just pinging it, pinging it, pinging it. It probably doesn't like that I'm doing that, but now that we know that that's working, we can stop doing that. All right, so let's edit this. Let's change our colors. Let's go to some sort of HTML colors on W3 or something. I'm gonna get a cool color, orange. Let's change it to orange. Yeah, give me orange. Oh, I guess I could just change the name to orange. No. Maroon. Okay, that's going to be different. All right, so let's go into our index.php, echo out our maroon color. Boom. And then ECS deploy 01. We want to see this deploy. So we've changed this now, and really what is defining our change is our version number. So if we go into my command line here, let's clear everything here. So you see it actually said that my service has reached a stable state. So we're looking good, and it exited perfectly. So let's jump into our Docker build. So we kind of go back into the beginning and look at our Docker build, and we have build the container name and the version. So I'm going to copy this, and since our version number now is different, we could change that to 1.0.1, and now it should make a new build. sudo docker images. We see it right here, new tag, great. All right, so we're gonna go now into our tag. We want to tag this to our repository. Sudo docker tag our container name, our version, our repository, and our version. Tagged it, and now we're gonna push it. I put the version name on the end of the push so it doesn't try to push through every version. So boom, change the one layer, small change, and now everything's up. So we should be looking good right now. Another cool thing is while we're doing this, you could do compose service PS, and we could see what services are running. So we could see literally that something is still running, which is pretty good for running if you're just trying to deploy your own software or just go to Heroku or something like that. But yeah. All right, so we should have our new version now up in our repository. Boom, version 1.0.1. Now all we need to do is do our last config, which was start. We're gonna do up actually, so it recreates that task definition and starts it. The task definition, we don't have to change anything now in our Docker Compose YAML because the version number right here is altered in our environment variable. If not, you'd have to go in and change that each time. There's different ways to do this, I'm sure. And apparently on the issues, let's see, new issues. There's a whole bunch of issues. There we go. So this is kind of, Kai Hendry actually spoke about it, but they said that there is no they're providing a forced deployment option, which shouldn't even be there. It should just be able to read it. But that's their workaround for it. So hopefully in the next, 25 days, someone wants it now. But hopefully in the next, soon, we have forced deploy. Either way, let's go here and let's run our change. So I'm going to go CLI and my compose, and I'm going to use my file, my Docker compose AWS file, and I'm going to do my service, and I'm going to run up. Now what I'm going to do is I'm going to come over here and I'm going to run a stopwatch so we can see how fast this moves. And then over here I'm going to run a fail so we can see if we get any fails. I'll get a couple because I have bad internet, but you kind of get the gist of it. So we ran that. Let's start this. And this is running. So you can see our task definition. It says update the ECS service with new task definition. Old containers will be stopped automatically and replaced. So that's great. We have a new task definition. So let's jump into here and check out our new task definition. And what this will do is show in our JSON here that our image is now 1.0.1. So now it's actually reading the new build that we pushed to our repository. It works pretty decently. You'd have to build like a little script or something like a build, .build or whatever sh, so to run all that for you. Basically what I have, just put it in a script and make sure it's clean and for your, what you're doing. But yeah, now if we go to task, we have a new one pending, and that's great because now we're still going to be pulling our old one until that one does the health check. So let's give it a moment and see when that runs. Okay, so about 15 or 30 seconds ago, it got up and running. So you could see our new task here is actually running. This is the one. And if we go to the public IP, we should see on port 80 our new maroon color, which is very hard to see. Not the best color to choose, but this is the old color, which is still running, and this is our new color. But it has not completed the health check yet in the load balancer. So until this one is healthy, it will not start draining the next one. And depending on how you like to run your application, you should set those parameters correctly. But for now, has a little bit of a switchover. But let's keep refreshing this because it should only take about how many? 2, so a minute to get through there. Let's reset this. So we know it's about 3.5 minutes, depending on your load balancer deployment, which isn't bad. Boom, it's changed. Okay, cool. So it switched over, and if I keep refreshing, there's no blue that's coming up. If we look at our deal here, we have 0 fails. So we switched from our old code to our new code with 0 fails, complete HTTP 200 coming back at us. So that's great. Everything worked. I think that's enough. Like, that wraps up. It's going to drain that other task and then close it out. But I think that wraps up kind of the gist of deploying using the ECS CLI. I think it's a great tool if you're running something very, very simple. If you're running something complicated at all, don't even look at it. This thing will drive you crazy. You just have to use the CLI, the ECS CLI in conjunction with the AWS CLI, and it tries to use this Docker part, but it doesn't really use Docker. It kind of just uses the YAML Docker-ish build, which you're not even going to be using because your local Docker doesn't use that. It just made everything a little bit frustrating. Maybe it's the best thing out there and I just don't know yet. But I need a simpler way to run a couple services at the same time in Amazon for my developers to use, really. But I think it gets you by and it works really well. I don't have auto scaling on here, but it's really good for that. Also, like, let's knock out of here, and then I could literally just go service scale, and then boom, now there's 2 tasks running, and you could just scale it up. I'm sure you could set up auto scaling and then put your whatever your alarms are and stuff like that. But like, it has some good things about it, but it also has some bad things about it. So there you go. There's Amazon ECS CLI. I hope that it doesn't confuse you too much, and I hope that it helps you guys. I hope that you could set something up in Fargate. It's a great service. You kind of get away from things. It's not perfect. It's still a little bit pricey. I wouldn't say pricey, but when you're comparing it or trying to sell it over an EC2 run instance, you really need to go and do a comparison based on your software that you're running and stuff like that. But I think it's getting there, and hopefully, they build other tools to use it, like Kubernetes, in the near future. But we'll see how it goes. Thanks for watching, guys. Like, subscribe. This is a super long video, but you made it. Catch you later.